Okay, the purpose of this video is to continue on in the tutorials about absolute value and inequalities. Now, in this particular tutorial, I'm going to show you how to do an absolute value problem where the inequality is less than some number. This is tutorial 4. In tutorial 3, I did an absolute value that was greater than some number. And in tutorial number 2, I did an absolute value that was equal to some number. Also in tutorial number 1, I did some definitions and I think a very simple problem, an equality problem there as well. But anyway, back to this. Let's go ahead and see how we can analyze this particular problem. Now you remember that an absolute value from tutorial number 1 is defined as the distance from 0, or the number of units away from 0. So for example, if I said my absolute value is equal to 16, I want to go 16 units out, right? And that would be 16 units away from 0. Now also remember that I have it on the opposite side. I can say negative 16 is also 16 units away from 0. So it's like you disregard whether it's plus or minus, right? You just want to go 16 units away from 0 on the number line. So with that in mind, let's interpret what this one is asking. This particular problem is saying I want my absolute value, whatever's in here, right, to be less than 16 units away. So I've got an inequality. What I would do is I would go out to 16, and then I want to, I don't include 16 because there's no equal sign there, and then I want to include all those numbers that are closer to 0 because I want to have it less than 16. Now when I go down here, look what happens. I'm still 16 units away here, right? But I want to get closer. So my arrow is actually ended up going in the opposite direction. So I have this kind of a graph. I'm basically saying that any point in here will be less than 16 units away from 0. So let's rewrite this now using our numbers and inequalities. I'm saying negative 16 less than the 3x minus 5, which is less than the 16. That's how I would write this, that's how I would write this number line as in inequality, all right? Now make sure you understand how to do that. If I were to flip this around, I'd say 3x minus 5 is greater than negative 16, right? So I'm going in that direction. This way it just follows whatever I'm doing. Okay, now once I've got this, I'm going to call that my step 2. We'll call this my step 1. Once I've got this, I'm going to break it up into 2 smaller problems. Remember what I always say, difficult problems are just simple ones that they've stacked together or put together. So I'm going to say, in my third step, negative 16 is less than, cover that up, 3x minus 5. I'm also saying that 3x minus 5 is less than positive 16. See how that works? And I'm going to solve both of these simultaneously and come up with 2 possible answers. And I'll show you how that works here in a second. So let's go ahead and start solving. Let me add 5 to both sides. It's going to make that a negative 11. And then I'm going to divide by 3, so I'm going to get negative 11 over 3 is less than x. And again, if you're like me, you don't like to see the variable on the right side, so I'm going to flip it around and do it this way, where x is greater than a negative 11 thirds. For some reason, that just makes more sense to me. I can see that visually a lot easier. Let's look at this over here. Let me add 5 to both sides. I get 3x is less than 21. Let me divide by 3. X is going to be less than 7. Okay, so now I've got my 2 inequalities. Let's go ahead and graph that and see what that looks like. And here's my new graph. There's my 0. Okay, so now I'm saying that my x is going to be greater than a negative 11 thirds, which is just between negative 3 and negative 4, isn't it? So right about there. And notice, follow the arrow. It's going in that direction. Negative 11 thirds. I'm also saying that my x is going to be less than a positive 7. So 1, 2, 3, 4, 5, 6, 7. And again, follow my arrow. And it's going that way. Let me just mark that. So I've just solved this problem. I'm saying that any point in here, when I put it into my original equation, will be less than 16 units away from 0. Now I'm not quite done. I still need to rewrite this using my interval notation. And what I would say is negative 11 thirds, I would have an open circle, so I'd have to put a parentheses, right? Then comma, all the way up to positive 7, again, open circle, so I put a comma. That would be my answer in interval notation for this particular problem. Okay? Now, one thing you could do, if you want to see if you did the right answer or not, is to check your answer. How do you do that? Well, you'll notice that my graph is divided up into really kind of 3 spots, isn't it? It's divided up into everything out here, everything in here, where the answer actually is, and then everything out here, okay? What you could do is just choose numbers from each of these 3 areas and see if they work. Now, according to my graph, only the numbers inside here should work. The numbers out here would not. So let's go ahead and check that just for the heck of it. It's always a good idea to do it if you can. So let's go to a negative 11 thirds. Now, notice what I said. It's between 3 and 4, right? So let's try negative 4, just outside the area that should solve, just outside the solution area. All right? So let's try negative 4. Now, here's my original problem, 3x minus 5. So I'm going to put 3 times negative 4 minus 5, absolute value, is less than 16. Let's check. 3 times negative 4 is negative 12. Negative 12 minus 5 is a negative 17. The absolute value of negative 17 is 17, but 17, this says 17 is less than 16. Is that true? No, it's not. And we knew that because this is outside the area that works, right? Let's try a number inside the area where we think it works. And just be random. Choose any number that works easy. How about, well, heck, let's just choose 0. Be easy to do. So I'm going to say 3 times 0 minus 5 is less than 16. Let's check that. 3 times 0 is 0. Minus 5 is negative 5. The absolute value of negative 5 is 5. Is 5 less than 16? Yes, it is. All these points will work. And again, if you want to go ahead and do the next one up, let's try something outside in this direction because it shouldn't work, right? Let's see what happens. Let's try 8. 3 times 8 minus 5. Absolute value is less than 16. I get 24 minus 5, which is 19. The absolute value of 19 is 19, and 19 is not less than 16. So this one and this one do not work. These 2 areas do not work. This is my area that does. Okay, I hope that helps. Let me go through the steps with you one more time, and then I'll let you go. When you start solving your absolute value, make sure that there's nothing around it, okay? Clear it away of anything that's multiplied or divided or added into it. So just go ahead and clean it up and get it like this. And then you got to interpret what this means on a graph. Whatever this number is, you want to be less than that number of units away from 0. Direction here, direction here. Then you want to take what's inside here and you want to say negative 16 needs to be in here, right? So it's going to be less than 3x minus 5. and 3x minus 5 is less than the positive 16. Break those up into two parts, solve them, put them on your new graph. Go ahead and write it in interval notation for your answer. Again, you can check all three of the areas just to make sure that you did it right. But if you followed your math, you should be okay. Okay, good luck. I hope that helps, and play this as many times as you need.